Hello everyone, thank you for signing in or watching this recording at a later time. Today I wanted to go through the solving algebraic expressions with substitution or conceptually. And at first we're just going to introduce the topic by going through some number properties, the properties of 0, 1, 2, prime numbers, and then combinations of even, odd numbers and with addition, subtraction, and multiplication, division. So I'm Mr. Matt. This is Dr. Tot. Thank you for signing in. And let me share my screen with you here. Okay. So first of all, there's a property. If you watch some of my other videos, especially last week in the Algebra 2 section, I've been going through the properties of addition and multiplication, the associative property, the commutative property, the inverse property, the identity property, the closure property, the distributive property. And so if you want to go, if you check that video out, that's an exhaustive explanation of all the different characteristics and tools that you have available to you to solve algebraic expressions. One in particular that involves the properties that kind of explains why 0 and 1 are so important, or they're unusual numbers, and that's the identity property. And there's two of them. So there's a property, identity property applies to addition and to multiplication. It basically tells you what value within each operation keeps the number or maintains that value's identity, creates no change within the value. So the identity property of addition tells us that some number plus 0 will always equal that same number. So with addition, you can kind of think of it as the magic number. The unchanging value is 0. The identity property of multiplication tells us that that number is 1. So a times 1 will always equal a. And of course, the commutative property tells us that order doesn't matter with addition and multiplication. So these things could also have been ordered 0 plus a will always equal a, and 1 times a will always equal a. So you can see 0 and 1 have important applications to addition and addition and multiplication respectively. Any number plus 0 is going to be that same number. It doesn't change. Any number times 1 is going to be that same number. It doesn't change either. So with 0, there are some unique characteristics that this number has that we want to review or make sure that we understand. First of all, 0 is an even integer. It's neither positive nor negative, but it is even. So 0 is an even integer. But it's the only number that's neither positive nor negative. Zero is also a multiple of every integer, because every number times 0 is 0. So it's a multiple of every integer. As we said before, any number plus 0 is that number. Any number times 0 is 0. So it's like the ultimate nullifier. You can have a string of a million values times each other, if one of those values is 0, the whole thing is going to nullify out. The whole thing cancels. So, and also a few more definitions. Any 0 raised to any number is 0. So if you, of course, because taking a power is just multiplying by itself. So 0 squared is the same thing as 0 times 0, which is 0. You can never, ever, ever divide by a number. So a divided by 0 is undefined. That means it doesn't work. Can't do it. 0 divided by some number, though, is going to be 0. The technical definition there, or the conceptual understanding that you should gain from that, is that division is the separation of values into equal groups. So if you take some number of items, let's say like 6 cookies, and you divide those 6 cookies equally among 2 people, each person would get 3 cookies. So 6 divided by 2 is 3. If you took those 6 cookies and divided them equally among 3 people, each person would now get 2 cookies, because 6 divided by 3 is 2. But if you tried to take those same 6 cookies and divide them equally among 0 people, that would be impossible. You can take 0 cookies and divide 0 equally among 2, 3, 6, a million people. It's just that each person would get 0, or get 0 cookies, get no cookies. But the takeaway there is that you can divide 0 by any number, and that would just be 0, but you cannot divide a number by 0. Also, a unique characteristic of 0, because 0 is neither positive nor negative, it's the only number that's equal to its opposite. So it's neither positive nor negative, so technically you shouldn't really, it would be inappropriate to write -0. But just to make a point here, I could maybe be a little bit more technically correct and say like -1 times 0. That's the same thing, because 0 can't be negative, 0 can't also be positive. It is its own classification with in that regard. And let's see here. Yeah, so 0 is neither positive. So when we say 0 is neither positive nor negative, what's implied there is that it is greater than all negative numbers, and it is smaller than all positive numbers. Okay, if you have any questions, then please let me know. I'll give you a few seconds there in case you want to take a screenshot of that. Make sure you have all your notes down. Okay, moving on. Properties of 1. So 1 is unique from the identity property of excuse me, from the identity property of multiplication, as we were talking about before. 1 times any number is going to be that same number. So that's one key that will be very relevant. So a times any number is always going to be equal to that number. Also, any number raised to the first power is that number. Exponentiating is multiplying it by itself a certain number of times. So if you only have 1 power, it's just that number standing alone. It doesn't have any partner to multiply with. So 3 to the first power is 3, 5 to the first power is 5. It's just the standalone value itself. 1 is an odd number. I'm going to say integer. 1, now this is very important. 1 is not prime. A lot of students think that 1 is a prime number. The technical definition of prime that we're going to get into later just a little bit, is that it's only divisible by 1 and itself. So 1 doesn't meet that definition or meet the standards of that definition because 1 is itself. So it doesn't qualify as a prime number, and that's really tricky for a lot of students. As you'll see in some of the problems, if you don't understand that, you can get a lot of these types of questions wrong because 1 is oftentimes included, as well as 0. They might ask you how many even numbers there are and include 0 in the number set. So if you don't count 0, you're going to get the question wrong. And then conversely, if they ask for how many primes are in a number set and 1 is included or -1 is included, and you pick that or you don't understand not to pick it, then you're also going to get that question wrong. So you do need to understand that's probably one of the most tested concepts out of all of these. Just as 0 is a multiple of every number, 1 is a divisor of every number. Because any number divided by 1 is that same number. And then also one last thing, 1 is the smallest positive integer. Let me move that up here. Give you a few seconds to make sure you have that down. If you have any questions, please let me know. And then there's not as many properties that we need to really talk about for 2, but there are a few important points that I want to get across. So 2 is the smallest even, or I should say the smallest positive even number. Two is also the only even prime. All other primes are odd because they are necessarily a multiple of 2. So it's the only even prime number. And the definition of an even number is that it's a multiple of 2. So it's a divisor of every even number, just by definition. Like I said before, if you have any questions, please let me know. Now I want to talk about prime numbers. Prime numbers are numbers that can only be divided by 1 and itself. And so a follow-on, what are non-prime numbers? All other non-prime numbers are called composite numbers. And they're composite numbers because they are made up or they contain or are the product of a unique sequence of prime numbers. So for example, if we take 30, let's just take 36. If I take 36 and divide it into 2 numbers that multiply evenly to get 36, I could maybe divide 36 into 6 times 6, both of which are not prime, so I can continue on. If I divide 6 into its prime components, that's 2 times 3. 2 is prime and 3 is prime, so in my factor tree, I'm going to circle those ending values. You can think of 36 of the unique product combination of the prime factors 2 times 2 times 3 times 3. Only 2 times 2 times 3 times 3 is 36, and there's no other prime sequence combination, product combination, that will get you 36. So you can almost think of that as like the passcode to the prime, like passcode or unlocking sequence to the composite number 36. So prime numbers make up or can be used to describe non-prime or composite numbers in their product sequence. And product, remember, means multiplication. Okay, if there's any questions, again, please let me know. Even odd combinations. So this is what's going to come up we're going to see a lot of this today with a little bit of a smattering of other concepts interlaced within the problems, but the even odd combinations are what we're going to focus on today. And I want to talk about the implications of even and odd numbers with addition and subtraction. And the implications with multiplication division. Okay, so I'm going to have this kind of chart going on. Okay, so if we have an even and we add an even number, so for example, like 2 plus 4, an even plus an even will always result in an even sum or an even difference. If you have an even plus an odd, that's going to result in an odd sum or difference. So like 3 plus 4 is 7. Odd plus an even is an odd. Excuse me. An odd plus an even here, odd plus even again is going to give us an odd. So like 5 plus 4 is 9. And an odd plus an odd will give us an even. 3 plus 5 is 8. So you can go through the kind of like thought experiment, or you can conceptualize it in a chart like this, and you can always write this out on a scratch, some empty corner in your testing packet and reference it throughout the test. So if you want to go through and figure it out once and write down the chart, that's fine. If you can just go through the thought analysis of it each time you need the particular detail, then that's fine too. And with multiplication division, it is a little bit different. So an even times an even will give us an even. An even times an odd will still give us an even. An even times an even will give us an even. Oop, excuse me. I'm sorry, I messed that up. This should be odd. An odd times an even will give us an even, but an odd times an odd will result in an odd number. If you have any questions about that, or just let me know in the chat function or in the comments below. If not, let's go ahead and look at some problems. Oh, I will remark this positive negative combinations. Let me just remark quickly. What I mean This doesn't have as complex of an interaction as the even-odd combinations that we just went through. Just notice that when you add to any negative times a negative times a negative is going to be a negative times a positive, which when there's just one value that's negative will turn negative. Um, but with addition or subtraction, with addition, it's going to take the sign of the larger value. So, for example, if we had like -8 plus 6, and that's really plus a positive 6, we don't always write two positive signs next to each other, but technically you have each number has a sign and an operator, so there's three signs, quote unquote, in any addition or subtraction sentence or any simple math sentence. So you can think about this as it always will take the sign of the negative value. So this is going to result in -2, and notice that -8 had the larger magnitude out of the two. But if this was +8 minus 6, then we would have a +2 because the 8 now is positive. Okay, so with addition, subtraction, it takes the sign of the larger value. With multiplication and division, if you have two of the same sign, then it's going to turn positive or remain positive if it already was positive. If only one of the values is negative, then they're going to turn negative. The result will be negative. If you have an odd number of negative terms, your result will be negative if you're multiplying or dividing. If you have an even number of multiple terms, or excuse me, of negative terms, then your number will remain negative because there's not going to be that extra doubling effect that eliminates the negative. You're going to have an odd number of terms, so that last negative multiple, when you multiply by that last negative number at the end, it's going to keep the result negative. That's the same thing, or very similar logic along the lines that any odd power will retain negativity. -1 to the third power is -1, but -1 squared is +1, because when we have an even set of numbers, even set of negative values multiplying into each other, they end up canceling, their negativities cancel out. But with an odd set of values, there's that last one negative that holds on at the end that will always turn those positive values, that each pair keeps on turning positive when you have two negatives. That combination or that result will ultimately turn negative because there's just one last negative number to multiply through. Okay, so let's look at this guy. I'm going to give you 2 minutes. Please look at number 1. Okay, so that was the 2 minutes. Let me give you some hints here. So this is an example. There's some real cross-sectionality here because this is also a question involving symbolism. So if x at sign y represents the number of even integers greater than or equal to x and less than y, what's the value of -2 at sign 5? So obviously at sign is not a mathematical symbol, but they're kind of making it up, or they're using this imaginary symbol in order to represent a concept that they are actually defining. So this represents the number of even numbers greater than or equal to x and less than y. So x is -2 and y is +5. So -2 at sign 5 is going to be all the values from -2 up to +5. Dr. Tot, do you need to go outside? I'm sorry, guys. I think Dr. Tot needs to go outside. I think the administrator, if you're watching, if you could come and get Dr. Tot, I appreciate it. Thank you. So we're talking about all the numbers from -2 to at sign 5. So from -2, we'd have -1, 0, 1, 2, 3, and 4. And we're talking about the numbers that are greater than or equal to x, but less than 5. So we're including -2. Then we'd have 0, 2, and 4. So there would be 4 even numbers between -2 and 5. If you have any questions, please let me know. Please take a look at number 2, and if you'll excuse me, I'm going to take Dr. Todd outside for just a quick second, and I'll be right back. Okay, I'll give you one more minute, and then I'll give you some hints. Okay, so if x at sign y represents the number of odd numbers greater than x and less than or equal to y, what's the value of -5 at sign 3? So again, they're totally making up this at sign thing, but they're defining what it means. it represents, and the key word there is it represents the number of odd numbers greater than x and less than or equal to y. X here is -5, y is 3. So we're going from -5, if we plot this on a number line, to 3. So -5, -4, -3, -2, -1, 0, 1, 2, and 3. And now we're greater than -5, but less than or equal to -y. So we can't count -5. It's exclusive to -5 because it's only greater than -5, not greater than or equal to -5. So skipping over -5, the odd numbers here would be -3, -1, 1, and then it's less than or equal to y, so we can count the ending value of 3. So we'd have 1, 2, 3, 4 negative numbers in between -5 and 3. If you have any questions, let me know. I'm going to actually put these two together. Please take a look at both of these questions. Let me make sure you can see both of them. Okay, so if we're looking at number 3, we're talking about the numbers between -2 and +2. So we have -2, -1, 0, 1, and 2. Now we're talking about prime numbers greater than x and less than y. So we can't include 2 or -2, even though, because 2 and -2 would be primes. 0, 1, and -1 are not primes. So there are 0 primes between -2 and +2. Now, if this said or equal to, then the answer would be 2, because it would be -2 and +2. But they didn't say less than or equal to, and they didn't say greater than or equal to. These inequalities were exclusive to their endpoints, so we could not include them. Okay, if there's any questions, please let me know. Number 4 represents all of the even integers greater than x and less than y. What's the value of negative 3 at sign 5? So we're going from negative 3 to positive 5. So we're going to have negative 2, negative 1, 0, 1, 2, 3, 4, 5. And we're greater than x and less than y, so we can't count the endpoints. And we're talking about all of the even numbers between these values. So we're talking about negative 2, 0, positive 2, and positive 4. So there are 4 even values in between these two numbers. Okay, if you have any questions, then just let me know. It's going to get a little bit more complicated. So these are multi-statement questions. And I apologize for the formatting here. Word went a little bit crazy and put in these these gaps when I was trying to make the question, so I do apologize. But these are the expressions that you're evaluating, just to be clear. And they're labeled statement 1, statement 2, and statement 3. And you're looking for the correct combinations that would work here. And so if A and B are even positive integers and C is an odd positive integer, which of the following would be even? So what you approach here, you can answer these types of questions in one of 2 ways. And here comes like the title of the video of solving conceptually versus substitution. Substitution you can always use by first identifying the domain of the values that they're talking about. So here they're talking about the variables a, b, and c. And so if you identify the domain of these values, or the acceptable acceptable values that they can obtain. So for a and b, they're even positive integers. So we're talking about numbers like 2, 4, 6. For C, it's an odd positive integer. So we're talking about like 3, 5, 7. As long as you pick a number to represent the variable that satisfies its domain, which you're allowed to do by the context of the question, then you can substitute in and just check which one of them turn out to be true statements and select those values. And that's always available to you. That's kind of like your fallback technique. But you want to get to a position where you can think about these things conceptually, because it's oftentimes a lot faster if you do that. So for example, A times B. So what I'm going to do, I'm ultimately evaluating whether these things are even or not. So I'm going to go back to that combination table of, even times an even produces an even, and even times an odd produces an even, and odd times an even produces an even, and an odd only, and odd times an odd produces an odd number. So if I go back to that theory, then if I have A times B, which are both even, then I'm going to have an even times an even. An even times an even will always produce an even value. Statement number 2, A times C. A is even, but C I know is odd because they defined it to be, so this is going to turn into an even times an odd. An even times an odd will result in an even number. So far statement 1 and statement 2 are true. If statement 1 and statement 2 are true, notice that I can eliminate statement selection C, I can eliminate selection A, and selection B, because they're all just only one statement. And looking at, so I don't know if 3 is right or is true or false. So D and E are my only options because one of them includes 3 and the other one doesn't. So I do need to go ahead and check 3. If it were a situation where there's no other option, so like, for example, if statements 1, 2, and 3 was not an option here, then I could immediately assume that the answer had to be D. Because if there has to be a correct answer in a multiple choice question. One of these selections has to be correct. So if one of them, if you know that statements 1 and 2 are true, then any statement that doesn't include those values would necessarily be false. So you can kind of use one statement being true or false to eliminate multiple answer selections, if that makes sense. But looking at statement number 3, b times c, is that even? So b is an even number, and c is an odd number. So again, we have an even times an odd. That's going to result in an even number. Okay, so the answer to number 1 is statements 1, 2, and 3. If you have any questions, please let me know. Otherwise, let's go ahead and look at this guy. And actually, I think some of my answer statements copied through, so I'm just going to make sure that all of them work out correctly. If I have to make any corrections, then I'll let you know. But I'm going to give you 3 minutes, and then I'll give you some hints. Okay, so let's look at statement number 1. We have a times b minus the quantity b times c. And a and b are even positive integers, and c is an odd positive integer. So we could say, for example, like a is equal to 2, and b is equal to 4, and then c is equal to 3, because a and b then would both be positive even integers, and c would be a positive odd integer. So they would satisfy the domain of the variables as listed in the context of the question, and we can merely substitute into each answer selection or each statement and verify whether it produced an even or an odd result, and choose the corresponding answer selection. But that's time consuming. You can always do that, and that's always available to you for like a fallback method. But we want to think about this conceptually. So A times B, those are both even numbers. So this is really the same thing. Actually, let me get another pen here so I can save room. So this is going to be even times an even minus B times C is going to be an even times an odd. Now an even times an even is an even, and an even times an odd is still an even. And an even minus an even will remain even. So statement 1 is not true. It's going to produce an even result and therefore would not be a true statement here. Statement 2, 2 times A times B minus 3. So what you want to do is insert the concept of even versus odd. It doesn't really matter what their numbers are, what the actual values. If I describe, I'm going to do the, actually let me do it this way. I'm going to do the even numbers in green and the odd numbers in red. So 3 is obviously an odd number, and then all the other numbers are even. So just characterize the values as even versus odd, and then take the relationships one at a time to look at what characteristic the result would be. Okay, I'm going to give you 2 more minutes. Look at statements 2 and 3, please. And then pick the corresponding correct answer selection. Okay, so if we look at statement number 2, statement 2 we can describe as an even times A is an even times another even, quantity minus an odd. So inside the parentheses, an even times an even would result in an even. So that's going to be even times an even minus quantity minus an odd. An even times an even, again, is an even, but an even minus an odd is going to result in an odd value. So statement 2 will result in an odd number. And then statement 3, if we go through the same type of characterization, 5 is an odd number, times A has to be an even number, times the quantity an even, times C, which is an odd, plus 3, which is an odd, times B, which is an even. So inside the parentheses, well, I can work actually everywhere here. So outside the parentheses, odd times an even, that will reduce to an even. The first pair inside the parentheses is an even times an odd. That's going to be an even. Plus an odd times an even, that's also even. So I'm going to end up with an even times an even plus an even. An even plus an even is even. So this is going to be an even times even, which will always result in an even value. And I'm sorry, let me move my screen up for you. So statement 3 will not be odd. So your answer here is going to be statement 2 only. If you have any questions, just let me know. Otherwise, let's look at 3. I'll give you 3 minutes. Okay, so let's look at number 3. A, B, and C are positive integers. If A is less than B, B is less than C, then which of the following is or are negative? So if they're all positive, the only way that we're going to get a negative result is if we have some type of small number minus some larger number. That will produce a negative result. So for statement A, we have A minus B. So instead of thinking A minus B, I'm going to think it says A is less than B. So I'm going to say that this is a small minus a large number. I don't know how relatively large it is, but yeah, that will reduce to a negative result. Because if you take a small number, if A is less than B, then if you take B away from A is smaller, so the result has to be negative. Statement 2, B minus C, so B is less than C. So we have a small number, again, minus a large number. This is going to produce a negative result. And we have statement number 3. Actually, I'm going to give you one more minute. Go ahead and evaluate statement 3 and see what the answer is. Okay, so if we look at statement number 3, C minus A, C is now the largest value because B is less than C, and A is less than B. B is less than C, so C has to be the largest value here. So if we have a large value minus a small value, that's going to reduce into a positive value. So if we have a large, relatively large minus a relatively small, that's going to result in a positive number. So statement number 3 is not going to be correct. So your answer here is going to be statements 1 and 2 only. If you have any questions, then please let me know. Otherwise, let's take a look at one more question. This will take us up to the end of class today, and we're going to end a little bit early today, and we'll pick back up on Wednesday. So I'll give you 3 minutes. Okay, so for number 4, now they changed A, B, and C are negative integers. And if A is less than B, which is less than C, then which of the following is or are positive? So what makes this especially tricky is that, remember, negative numbers are opposite conventional, what you would conventionally think of in our relationships, or how numbers compare to each other. With negative numbers, the higher the magnitude, the less the value. So for example, it would be better for you to owe somebody $1 rather than owe somebody $100, right? So -1 is actually a larger number than -100. -100 is a smaller number than -1 because it's more negative. It's farther to the right from 0 on a number line. Excuse me, to the left. Excuse me. Um, so when we're evaluating here, we're really just concerned about what happens inside the parentheses, and then making sure that we apply, consider that there's a negative that's going to multiply to all of that whole quantity inside. So A is less than B. So if we had, for example, like -2, if I picked numbers to represent all of these guys, so if A is less than B, so let's say that A is -3, B is -2, and B is less than C, so let's say that C is -1. Notice the counterintuitive nature there. A is the smallest number, but it has the largest magnitude because they're negative numbers, right? The larger the magnitude, the less the value if we're talking about negative values. So if I substituted these values in here, I'd get -1 times the quantity -3 minus -2. -3 inside the parentheses, we have the quantity -3 minus -2. You can do the little leave change to make this a easier to work with expression. Leave the first sign alone, change the sign of the operator, change the sign of the second number. So -3 minus -2 is the same thing as -3 plus a +2. And so that's going to be -1 times -1. -3 plus a +2 is going to be a -1. -1 times -1 is a +1. So statement 1 is true. Statement 1 will turn into a positive result. Statement 2, we have A times the quantity B minus C. So substituting our given or our assumed values, we'd have -3 times the quantity -2 minus -1. If we do leave change, leave this sign, change that sign, change that sign. -2 plus a +1 is the same thing as -1. So this turns into -3 times -1. And that's going to be a +3. So statement 2 will also turn positive. And we have statement 3, B times the quantity C minus A. So if we assume B to be -2, if we assume C to be -1, and we assume A to be -3, and then we do leave change here, leave the first sign alone, change the operation, change the sign of the second number. -1 plus a +3 is going to be a +2. So this is going to end up being -2 plus a +2. That's going to be a -4. So that's not going to be true. That's going to result in a negative number. And so your answer here would be D, statements 1 and 2 only. Thank you guys very much for signing into my live stream. We'll pick back up on Wednesday with more questions like this. If you have any problems or anything's confusing, if you have any questions, please drop me a comment in the comment box below. Also, look out for the links on my Facebook page. You might want to add me as a friend and subscribe to my YouTube channel if you found this to be helpful at all. I broadcast every day from 3 o'clock, 3:10 technically, to 9:45, covering SAT prep, mathematics among 4 different grade levels, high school grade levels, and reading and writing exercises among the 4 high school grade levels as well. Thank you guys very much again, and I hope you have a wonderful day, and I'll talk to you all on Wednesday.